Hello, everybody. It's good to have you with us. Welcome to the second of the Rescale Solutions Live webinar series featuring hands-on demonstrations of the top science and engineering applications on Rescale. So my name is Jolie Hales, and I will be your moderator here. And today's focus is on automating Ansys workloads on Rescale with REST APIs, including HFSS and mechanical. And let's go ahead and switch my slide here. So we have two speakers lined up for today. The first is our special guest, Wim Slachter. Wim is Director for High Performance Computing and Cloud Alliances at Ansys. And in his role, he is also responsible for the overall design and execution of the Global HPC and Cloud Partner Program within corporate marketing at Ansys. And prior to that, Wim was the lead product manager of HPC. He was also corporate product manager for the CFD product line and the business manager for the Explicit Dynamics and Offshore. Before joining Ansys in 2003, Wim worked at MSC Software since 1994 in various management positions related to software development, consulting, and sales. Wim holds a PhD in aerospace engineering from the Technical University of Delft in the Netherlands. And then after Wim, we'll hear from Riaz Liakoth, who is a solutions architect at Rescale. He loves solving challenging scientific problems quickly and efficiently by leveraging the cloud and by thinking about problems from both a 30,000-foot level as well as a deep dive. He has a master's in electrical engineering and comes with strong expertise of running electromagnetics and multi-physics simulations to build innovative products. You guys both sound awesome. So at this time, I will go ahead and turn webinar control over to Riaz for slides. And Wim, good to have you with us.
Yeah, thank you, Jody, for your very kind introduction and for inviting me to your webinar. So and giving me the opportunity, to share my perspective on cloud computing for engineering simulation. But before doing so, I'd like to say a few words about challenges our customers are facing and the role engineering simulation can play to address these challenges. So as you can see on this slide, there are a lot of challenges. And Neil is mentioning that we live in an extremely and highly competitive landscape. And manufacturers can clearly see all kinds of challenges in terms of shortening the time to the market, reduce development cycle times, and also increase the number of product rollouts. And it's evident that all of them are pressured to produce more and better designs faster than ever. Next, Riaz. But I can also say, particularly to this slide, that the digital revolution is making manufacturers' lives even tougher. Yeah? As you can see, significant technology disruptions manufacturers are facing. For example, on the top here, you see chips are more complex and sophisticated than ever. Yeah? And soon, every product will be connected. Yeah? For example, in the past, a thermostat more or less only contained a bimetallic strip. But nowadays, you know, the thermostat is connected to the internet so that you can have full control and monitor the temperature in your house remotely. Yeah, and more products are now also the gateway to the Internet of Things. Yeah, you connect. You can read the media today without coming across the latest development in autonomous vehicles and so on, yeah, with cars, drones. So all examples, I would say, of technology disruptions that manufacturers are facing. Next slide, please. And simulation, yeah, is the answer. Yeah? Engineering simulation, to be precise. And let me tell you the reason why on the next slide with some proof points. According to a very large study performed by the Aberdeen Group, simulation has a lot of benefits, like being able to deliver faster product development than relying on physical prototyping, and more cost effectively with more confidence. And product launch targets can be met, as you can see on this slide, by 21% more companies if they have simulation users. And quality targets can be met by 17% more companies having simulation users. So simulation, engineering simulation is critical to the success of organizations. Next. So over time, we at Ansys have been consolidating our platform because we know that this will help our customers to decrease the development time and more likely meet product launch targets. And working with our leading customers, with leading partners, including Rescale, we have implemented and made available new features for process and data management, as well as features for process integration and design optimization. And our platform is also by design open for other tool extensions. And we work with a very wide ecosystem of HPC, of cloud partners. And I'm very pleased to be in this particular webinar and to share capabilities with you. Next. And there are different ways to articulate the value of HPC for engineering simulation. And I often explain it that HPC enables engineers to consider more design variants, more design ideas, make more efficient product development decisions based on better understanding of performance trade-offs, as you can see on the left. But at the same time, HPC brings value because it is it is a key enabler, I must say, for getting higher fidelity insight into product performance, insight that cannot easily be gained any other way, because it allows you and other engineers to simulate larger, more complex models and even systems so that more accurate design decisions can be made throughout the development process. Next, please. Actually, this slide comes back to a survey that we've performed among about 610 engineers, or at least we got over 600 respondents back from engineers, engineering IT managers, from decision makers, in which they shared actually their perspectives on the use of cloud-enabled simulation. And when we asked the respondents to rank the engineering benefits as highly important, this graph showing here shows the outcome. And maybe not a full surprise to some of you, but the top three were increasing speed of product development, improving engineering productivity, and accelerating innovation. And the fact that the top three are high performance computing related is not surprising. And so let me just share with you on the next slide why people are more and more adopting cloud computing for engineering simulation. On this slide, I'm showing actually the survey response on organization situations regarding the use of cloud computing for engineering simulation application. 17% of the respondents are using the cloud for engineering simulation today. And of those using cloud for engineering simulation, 46% are out of the pilot stage. And if we break it even further down, 27% have moved production engineering simulation workloads to it, to the cloud. And 90% are using it for business critical workloads. So cloud is real. And I can also say that another 20% is planning to use it over the next 12 months. So cloud is real, and I'm happy to share these perspectives with you. And I will now hand it over further to Rayas. Raz, please go ahead. This is, sorry, perfect. I forgot about this particular slide that I was still supposed to share this with you. But indeed, there are passes, different passes to simulation on the cloud. Three basic cloud deployment models, and we have Ansys simulation on the cloud. On the left-hand side, Ansys Cloud, which provide instance access to on-demand HPC in a Microsoft Azure cloud from within the Ansys Workbench environments, for mechanical, fluent, electronics, desktop. On the right-hand side, we have custom managed solutions for people who have very unique SLA requirements, for example, or security requirements or demands on compliance and so on. But most important, for this, and in particular, addressing topic of today's webinar is the third deployment model, a very important one, working with partners, meeting very specific hosting requirements, often by containerized resources, with no shared tendencies. So again, very happy to work with Rescale, and thanks to a long-standing partnership, happy to be in this call. And go ahead, Riyaz. Looking forward to your talk and your demo.
Perfect. Well, can you hear me well?
Yeah.
Awesome. Thank you, Jody. Thank you, Wim, for a great introduction. So that was very insightful, helps us put some perspective and color as to why cloud and HPC simulations becomes very important for the CAE space. Good morning, good afternoon, everyone. My name is Riyaz Diakad. I work as a solutions architect with Rescale. In the next 40 minutes or so, I want to spend time talking about what Rescale as a product is, what is the value that we bring to you, how we can help solve challenging problems in the cloud. More importantly, the meat of my presentation today is how you can use APIs to automate your workload. Automation is very powerful, and understanding what are the use cases and how to write automated scripts becomes very important as we all are becoming a very agile organization. Adding to what Wim was talking about, Rescale and Ansys have a long-standing relationship. We are a strategic solution partner. We work with a lot of customers in the CAE space to make sure that all of the Ansys workloads can successfully run on Rescale. So let's dive deep into it. So what is Rescale as a product? So Rescale is a multi-tool and a multi-cloud SaaS-based platform to run high-performance compute simulations on the cloud. We are multi-tool in the sense that we support commercial applications like Ansys. We can also, customers can also bring open source applications such as, if you want to run a TensorFlow model, or if you want to run open form CFD simulations, you could do that as well. Or if you have your own custom application or a custom version of the application, you can bring that to Rescale and run it across any of the public cloud service provider. So that's really the value here. So if, let's say, for example, I want to run an Ansys workload on AWS, I don't necessarily have to know and understand all the different cloud technologies pertaining to AWS. I don't need to know how to configure my IAM, security group, S3, so on and so forth. So Rescale is one layer of abstraction on top of it. And because of this, all you have is a very easy turnkey platform where you can, with a few click of a buttons, you can run any application on any public cloud service provider. So to summarize, what is the value that we bring to you? First is application management. So we can install any of these different applications. There are close to 400 plus on the platform, and the list only keeps growing. The second is multi-cloud orchestration. In the sense that we can work with any of the public cloud providers in any fashion. And the third is enterprise-grade security. This becomes very important when we work with enterprise customers, because most of the times you might have large number of users with different groups across different geos, and there could be like very specific InfoSec policies, right? For example, an enterprise organization would require ITAR compliance or FedRAMP compliance. So Rescale has technologies to meet all of those requirements. And the last and the big piece I would say is when users are running jobs on cloud, understanding how to manage the users, budget, and licenses, all these becomes critical, right? And Rescale has a platform for governance where you can go and set up specific policies around how you want to manage your HPC spend. So when we talk about Rescale as a turnkey platform, what are the different things that we are automating and making it easy for you? We manage everything from the application layer to the infrastructure and everything in between. Let's say that you want to run an Ansys workload, right? So we make sure that we take care of all the pieces in between. So we spin up license server, make sure that your license ports, everything is configured correctly. If there are any dependencies around the workload, we build that as well. We make sure that all the compilers, networking, storage. So all these things are taken care and managed by Rescale so that essentially you have a SaaS-based turnkey platform. To go one level deeper into how Rescale as a platform works, is let's say that we have users who are on-prem, so they create their own models of CAD. Let's say I want to run an Ansys Fluent workload, right? So I go and create a model in Fluent where I set up my boundary conditions and everything. And from that point, they can upload the data to the Rescale platform. And when they are uploading, we do have API-based authentication, so which provides secure access. There are 3 ways how you can connect to the platform. I'll talk about that in a minute. But inside the platform itself, I would say like we have all the elements and pieces necessary to successfully run a workload in cloud. So we have the application piece, which we spoke about. We have applications catered across like a variety of verticals. The second, the big piece is the infrastructure automation, right? So when you submit a job, so essentially there are a lot of steps that are involved here, right? First, we have to go stand up a cluster. We have to attach the application, and the application terminate the cluster. All these are orchestrated to our API, and all the pieces that is required in between, such as license management, networking. Some workloads, for example, might require InfiniBand for high performance. So we also configure those types of networking pieces as well. The last is the security and monitoring of the jobs as well. So when you run the jobs, it's very important to understand how your job is running. Is it going to converge well? So we have all those pieces automated. And the job itself, let's talk about it. What are the different pieces that you need to successfully run a job? First thing is obviously need the storage. When you on the Rescale platform, we have both block and object-based storage for different types of workloads. And then we have virtual machines across different cloud service providers. We have a total of 52 different types of architectures. These could be a combination of high memory nodes. Some of the nodes could have high InfiniBand. Some can have high IOPS. So there are a variety of options, and we, based on our experience working with many customers in this space, we are able to provide recommendations on what type of hardware is well suited to run your application. And the last piece is when we talk about running jobs on Rescale, there are 2 types of jobs. One is a batch or a non-GUI job. And the second is when you want to run a job interactively through a VDI. We do support both, and we do have VDIs with different technologies such as nice TCV for low latency and high performance. So that's kind of all of the pieces of the Rescale platform. So let's talk about how you can actually submit the job. So that's the part that we are going to focus in our talk today. The most common way would be to go to a web-based UI, which we have, and you can go and click through the different steps to submit a job. That's what most of our customers do. We also have a CLI-based utility, which lets you do specific tasks such as, submit a job, download files. It helps you to perform a reduced set of action. Now, the third one is where you can use API to do a variety of tasks, not just submitting a workload, but you can also automate the workload, build different types of pipeline. So in this talk, we'll talk about how you can use APIs to build automated workloads. So before we go there, let's first try to understand what is REST API. I know a lot of you might be hearing this new. So just want to give a brief primer as to what this actually means. So Rescale is built on top of REST API. REST API is one of the frameworks that is well suited for a distributed system like Rescale. So using these APIs, you can build intelligent scripts that helps you to perform some desired action. Some of the common principles of REST API, such as it is well suited for a client-server-based architecture, which is true in this case. So if you are submitting jobs, you are going to be the client, and the server is going to be the Rescale infrastructure, right? And then the other pieces, such as when you submit jobs, you also have this is going to be a stateless communication. So where you have to provide all the payload information to specifically tell, like, hey, this is my job, this is my version, this is my license. So you provide all those information so that that task can be executed and to get to a desired action. And because this is all built through API, so it provides a very uniform interface for job submission, right? It's not unique for every submission. So it becomes very, very easy to automate how to submit jobs. The last part is a layered system. So in this case, the Rescale system is a layered system because we have a web server, we have the infrastructure piece, we have the license management piece. So there are a lot of different elements which form the Rescale platform, and all those things are built through APIs. Now, with that, like, let's say that I have a good understanding of APIs. I want to go build scripts. Like, what benefits do those actually provide to you? Automating job submission is definitely one. That's a big piece. But it also helps and gives you flexibility to build custom workload pipelines. So I'll give you an example. So I have one of our customers working in the life sciences space where they are doing a genomics pipelining. So they have to go through 26 different stages. And for some stages, you might need a high memory node. Some stages might need high IOPS. Some might require low memory nodes. So using these APIs, you can build this type of pipeline and automate this whole submission process, right? And I'll also show you that we have a repository of all the endpoints available on our platform. It is all well documented, which makes it easier for any user to get started in building scripts. Let's take a couple of minutes to understand what are the use cases for automation, right? When we say automation, all of us can get very excited, but I think it's very critical to understand which use cases would actually benefit from these type of automation. So I'd say, like, there are four unique cases where APIs can be very powerful. First, and the common one, is automating batch workloads, right? So instead of going through the UI and clicking multiple buttons, so you can write a simple script which lets you submit a job with a single click of a button, right? And now sometimes I might not want to run just one job. I might want to run hundreds of jobs at the same time concurrently. Now I can write a script to submit all those 100 jobs instantaneously. So that's the power that a scripting can give to you. The second one is automating multi-step workloads. We'll touch upon this a little deeper in the later half of our presentation. But when we take some common CAE workloads, all of them have two steps. The first step is a meshing step, and the second step could be a sweep. This could be a time sweep or a frequency sweep, depending on the type of workload. Sometimes you might want to run those steps as separate jobs for good cost performance. So APIs helps you to build flows for that, where you can run workloads with multiple steps. The third is design of experiments or database runs, right? Let's say, for example, I'm going to build an electric vehicle and I have a parametric CAD model. So I want to see that if I vary the parameter of my CAD, how does my aerodynamic drag look like, right? So if I want to understand that type of analysis, obviously I have to go and do like a design of experiments, or I need to run a database of simulations and collect the data from it to come to some conclusion. I could either say that, hey, my design is great, I'm killing it, or I could say that, oh, I need to go and improve this particular aspect of my design, right? Now, API helps you to build those type of design of experiment workloads as well. The last and the big piece, I think, is the multi-tool orchestration. So if we take enterprise workloads, on an average, we've seen that they use at least 15 different tools for their product development. This is from the ideation phase till the product is out of the door and into the market of hands of the customers. So in this space, so what the typical process looks like, hey, I want to run job 1. This is the output of job 1, which is fed as an input to into tool 2, so on and so forth, right? So I can write powerful scripts to build a multi-tool orchestrated workflow. All right. So just to recap what we spoke so far. So we spoke about what Rescale as a platform is, why automating through API is very powerful and helpful for you. And we are going to look at a couple of use cases such a deep dive. And what I'll also be doing at the later half of this presentation is also I'll be giving a hands-on demo on how to write scripts for these two use cases. Right? The first use case is automating batch workloads. So here, what I want to do is I want to run an Ansys mechanical workload on the Rescale platform. So I can go through the UI. The flow looks very simple, right? So I need my input file. So most of the time, users would build it on-prem, so you can do all your pre-processing on your local machine, and then upload to the Rescale platform. I attach my input file. Next is I'm going to choose the software of interest. So here I'm going to say that, hey, I want Ansys Mechanical. I want to use the 2020 R1 version, and I want to bring my own license. We support 2 different licensing models. You can either bring your own license and use it to run jobs on Rescale, or you can also use Ansys Elastic Units as well. So let's say in this case, I want to bring my own license. So I specify my license server settings and everything. And then I choose my hardware. I want to run it with this type of hardware, and I want to run this with 18 cores, for example, right? So I have to specify all these different inputs for me to set up this job. And once I set it up, then I can go ahead and launch this job. So let's see, let's try to understand how API can automate this whole workflow, right? I want to talk through this architecture because it helps you to understand the data flow. So here we have like 2 pieces. One is the customer piece, which is on-prem, and the other is the Rescale piece. So here, now if we are automating this whole workflow through an API, essentially what would happen is the user would build his input file, and then you would submit an API script. The API script, what it does is it automatically takes your input file, uploads it to the Rescale platform. The API would then go and launch a compute cluster. Files would automatically get transferred from your cloud storage to your compute cluster. The job would run, and these could be multi-node jobs where you have a master and slave. So all these things are configured. And then in this case, like I'm also using a licensing which is hosted on Rescale. So all this information is taken in, the job is run. Once the job is completed, this cluster is terminated and the data is transferred back on-prem for the user to review, right? So now what we avoided is like, we, instead of going to the platform and doing all these steps, so we are essentially just submitting a single script, which is going to build this workflow for us. So what is the benefit here? So we went from 10 most clicks to just 1 click using an API. Let's talk about another interesting use case. This is for automating multi-step workflows. The candidate I have for this use case is HFSS, which is an Ansys tool used for electromagnetic analysis. It's used for a wide variety of applications such as 5G and ADAS for building wireless systems. You'll notice that it's a very highly memory dependent workload, so it typically requires high memory machines to run this job. And if we look at the typical process, so it contains 2 steps. The first step is adaptive meshing. So adaptive meshing usually tends to be like a single node process. And then once the step is completed, then the tool can do the frequency sweep, which can be a multi-node process, right? Now, I'm going to say that for large models, it is recommended to use a multi-step workflow for optimum cost performance. I'll tell you why I made that statement in the next couple of slides. So let's take this use case and let's pause for a moment and forget about multi-step workflow, right? Let's say that we are going to be running this as a single job. Let's try to understand what's going on and what's the scenario here. So user has built a beautiful PCB design and then submitted jobs to a Rescale cluster. So here, let's assume that this job requires at least half a terabyte of RAM for the adaptive meshing, and he also wants to run like 20 frequency sweep points, right? So considering all these things, the user decided, okay, so I'm going to go ahead and build a 3 terabyte node. So it's going to be like a multi-node cluster, and the job launches. The adaptive meshing is running. It's going to take, let's say, that 10 hours. So in this 10-hour period, what's happening is adaptive meshing is running only on a single node, while 2 other nodes are sitting idle, right? So till this process is completed and gets to the frequency sweep, all the nodes cannot be used. So here, what's happening is the user spun up a big cluster, and then some nodes are idle, and the user is paying for idle cluster, right? So now idle cluster is something we all don't like, and the reason being idle cluster leads to wastage of resources and money, right? So this is not the way to be running this job. So how can we do it better? What can we do here? Let's take the same workflow again and let's architect it in a different way, right? So here, same type of job, but instead of submitting as a single job, I'm going to be submitting as a 2-step job. The first part of the job is going to be a single node job where I'll be running adaptive meshing. And once this job is completed, it will automatically launch the second job with a multi-node cluster for the frequency sweep process. This whole workflow is automated through an API script. So the API script does 2 things here. The first thing is it does node right sizing. So for each job, we are deciding what is the right node and resources required. So that's the first benefit. And the second benefit is the API script automatically handles all this job dependencies, right? So you don't have to go and manually wait for your first job to complete and then go launch the second job. The script will automatically decide that, hey, this first job is completed. I'm going to start my second job. And I looked at the memory of my first job. So depending on that, it looks like I might need 3 different nodes. It makes all those intelligently decides what is the hardware configuration required and goes ahead and launches the second job. So now instead of building this complex workflow, the user has to do is just click a single API script to get everything done. I hope that gave a good idea about Rescale, how to run API-based workloads, and a couple of use cases. In the next 20 minutes, I want to spend some time going over a hands-on demo on first showing you how to run a job via the UI. And from there, you'll also see how to do the same via API scripts, right? How can you go and start building it? So let's dive into the platform. So I'm logged inside the Rescale platform here. This is how it looks like. And inside the platform, I can run two types of jobs. I can run a batch workload. I can also spin up desktops and do a desktop-based session. For this demo, let's consider that the same example. Let's go to use case number 1, where we want to run an Ansys mechanical workload, right? So if I have to do it through the UI, so how does the flow look like? First, I can go and create a new job. So I'm going to give this job a name. And when you, first step here is to attach an input file. If you have files from your local machine, you can upload it. Sometimes you might already want to use files from your cloud storage, which is what I'm going to be doing for this demo. So let me search for the file from cloud storage. So I need a .dat file. Perfect. So I have an input file. Next step is, let's go ahead and choose a software. I'm just going to scroll through the list to see the amount of softwares that we currently have on board. And this is used for a wide variety of verticals. In this case, we want Ansys Mechanical. So let's search for Mechanical. So I see Ansys Mechanical. And once I have a software, I can choose a version of interest. So let's go ahead and pick the latest one, 2020 R1. And then the command line is automatically populated. You can use your own license. In this case, I'm going to do this license via a demo license. So here I'm going to choose a Rescale trial license. Okay, so let's recap a bit what we did. So we have our input file. We have our software where we specify the version, the license settings. And the third step is to run the job. You need to tell the platform what hardware that you want to use. So there are like close to 50 different options. All these are different virtual machines from different cloud service providers. There are a variety of options. Some are high memory, some contain high clock speed. In this case, let's say that I'm going to be using a small virtual machine, right? I'm going to be using the Onyx node, and I am going to be running this job with, let's say, 4 cores, right? So I choose my core type, and I choose a number of cores. Let's go to the next step. Post-processing is purely optional. So in this case, let's skip that. So here we have configured our job and we are ready to launch. So going through this flow, we learned 2 things. One, we learned about the Rescale turnkey platform solution, right? With a few clicks of a button, you can go ahead and launch jobs easily. The second thing is we also learned that you have to click 8 to 10 different buttons to do this, right? And sometimes you might want to run hundreds of jobs and you might want to automate this whole flow. That's the whole point, like why we are going to be writing API scripts to do the same thing. So let's see how we can do the same desired action via an API script. For us to get started with the API script, so first we need 2 things. Every user, when you sign up on the Rescale platform, each user is given an API key. The API key is unique and it's only through an API key we are able to authenticate the user and tell that, hey, this user is part of this organization. He has access to licenses and credits to run a job, right? So API key is very important. So first thing that you need before writing an API script is to generate a key. The next is the documentation. So the documentation is where we contain information about all the different endpoints perform different actions, right? We support some of the common methods such as get, post, put, everything which is common for an REST API framework. And then if you want to perform specific actions, right? So let's say that hey, I want to submit a job. What is the way to do it? Where is the endpoint, right? So I can go search for a save job, and now I can, if I scroll to the top, so I can basically get an endpoint for that. So by going through this documentation, you can find endpoints for any type of action, right? So you can run jobs, you can do specific tasks, you can poll a task, so on and so forth. In this example, what we are going to do is we are going to be creating a simple script to upload your data. To choose your analysis, you're going to say that, hey, I want Ansys mechanical. You're going to be setting up a job with the right code type, number of cores, everything, and then you're going to be submitting a job, right? So 4 simple actions. So let's see how we can build this type of script. So go here. So I'm inside my API script where I can do a single run with an input file, right? So first, so I specify what is my API token. I can say that, hey, I want to upload a particular input file. So I'm going to be using this endpoint with a post request. So I'm going to say that this is my input file. Please upload that. And once I upload an input file, then we are going to be building the payload, which is necessary for a job, right? So payload is nothing but it contains information related to the job. So for example, you're going to tell like what is the name of the job, what is the code that you want to use, what is the version of the code, command line. If you want to run this job with 4 cores, you tell that. You can, and then you can also specify what type of licenses that you want to use. So all these things are part of your payload. So once you have your payload, the next step is you're going to create this job first. And then once the job is created, then you are going to submit, right? So it looks fairly simple. So you upload a job, you create a payload, you create a job, and then you submit a job. Now let's say that I don't want to upload input files all the time. So if my input files is like 300 MB, like I don't want to keep doing it. I want to use an input file which is already available on my cloud, right? Hey, so how can I go ahead and do that? Sure. So in order for us to do that, so for that case, what we are doing, we are skipping uploading the input file step, and then we are going to say that use a particular input file from my cloud storage, right? And how do you find what is the ID? So if you go back to the platform, so when files are uploaded to the platform, each file is given a unique ID. For example, if I want to use this file, it's going to be a file ID, right? So I can get that file ID information, and then I can build it as part of my script. So let's go back to our script here. So here, like I'm telling that I want to use a particular input file, and then I want to launch this job, right? So with that, let's see what happens if we actually launch the job. I'm going to create a terminal here. Okay, so we have like multiple scripts here. So the script that we are going to be running is just a single run without input file, right? So let me go ahead and launch that script. I want you to pay attention to the jobs page here. So right now you can see that there are no jobs launched yet from the API. The Ansys demo is the one we launched through the UI. What happens if I launch this particular command here? So you can see that immediately a job was created and the job started launching, right? So that's really the power of API. So using the single script that you can launch the job. So now sometimes I might also want to launch not just one job, but multiple jobs. So how do we do that? In order for us to do that, so let's go back to another use case. So here what I'm saying is I want to run this Ansys mechanical job, but simultaneously I want to run this with 4 cores, 8 cores, and 18 cores, right? So maybe I'm doing a benchmarking so to see how the performance looks like. There are a lot of different use cases. You could also write scripts to launch jobs sequentially, one after the other, checking licenses. But here I want to run 3 jobs concurrently using 4 cores, 8 cores, and 18 cores. So let's go back to our terminal again. This case, the decide action is after I launch my script, you should see that 3 jobs are concurrently launched, right? So let me go ahead and launch this job. And let's pay attention to this window here. So you can see that immediately 3 jobs started launching. So with just one click of a button, we are able to do this, right? So that's kind of covers the first use case where what happened is, so I can do a single job or I can run multiple jobs concurrently. The last part that I want to cover is the second use case. If we just go and recap this for a bit. So essentially in this use case, what we are going to be doing is we are going to be running a 2-step job. After we launch the first job, it should automatically launch the second one, right? And how does that flow look like? So here I have a particular script which I'm going to open in a moment. But essentially for you to run this job, so we are going to do a 2-step job, which is dependent on each other. The first is I need input file for my first job. So I'm going to run a HFSS model. It's going to be an ADETZ model. And after I run my first job, then I'm going to automatically launch a second job, right? So in order to do that, I need a credential file which is going to authenticate and allow me to launch the second job. And I also need a frequency sweep submit script. So what this does is after the first job is completed, it automatically uses this to build the job submission script for the second part of the job, right? So let's go ahead and try opening this. So we're inside the HFSS submit script. So here, the flow looks very similar. So you have your API token. So you're uploading whatever input file is required for this job, and then you're building out your payload. Now, where we build intelligence on how to run the second part of the job, the magic lies in command here, right? So in the command, it's a long one. So if I scroll to my right, so essentially we are saying that, hey, run my first part of a job. And then we are saying that run only the adaptive machine. So we are doing that using this particular flag. And once this this is completed, then we are going to be calling our .sh script. We are going to be calling our credential files, and then we are going to be using all this to launch the second part of the job automatically, right? In this, we also say that this script also looks for how much memory is used by the first job, and then it intelligently decides what should be the memory for the second part of the job. So let's go ahead and submit this job as well. So let me go up one level. So I'm going to cd to my HFSS folder. And then I'm going to be launching my HFSS submit script. So if I do that, you should see that desired action is the first job should launch. And then it usually takes like 15 minutes to complete the first job. And once that's done, then it will start launching the second job. So you can see that because of our script, the first job has automatically started. So this job will take anywhere from 8 to 10 minutes to run. But essentially, once this job is completed, it will go ahead and create this second job. And then this will run for like 20 minutes and then generate the output. We can't wait for this job to complete, but I hope that gives you an idea of, what is Rescale, how is API useful, and how to actually go ahead and build your own scripts to perform these type of action. Thank you.
So if anybody has any questions, you can go ahead and type those into the little question window. Well, Women, Riaz, it looks like you covered everything. So with that, we can go ahead and wrap this up. Thank you so much to both of you for presenting. Have a great day and stay safe out there.